Hello, so today I'll be speaking on the topic about torque. So let's start with what is torque. Torque is a measure of the force that can cause an object to rotate about an axis. Just as force is what causes an object to accelerate in linear kinematics, torque is what causes an object to acquire angular acceleration. Torque is a vector quantity. The direction of the torque vector depends on the direction of the force on the axis. Anyone who has ever opened a door has an intuitive understanding of torque. When a person opens a door, they push on the side of the door furthest from the hinges. Pushing on the side closest to the hinges requires considerably more force. Although the work done is the same in both cases, the larger force would be applied over a smaller distance. People generally prefer to apply less force, hence the usual location of the door handle. Torque can be either static or dynamic. A static torque is one which does not produce an angular acceleration. Someone pushing on a closed door is applying a static torque to the door because the door is not rotating about its hinges despite the force applied. Someone pedaling a bicycle at constant speed is also applying a static torque because they are not accelerating. The drive shaft in a racing car accelerating from the start line is carrying a dynamic torque because it must be producing an angular acceleration of the wheels given that the car is accelerating along the track. The terminology used when describing torque can be confusing. Engineers sometimes use the term moment or moment of force interchangeably with torque. The radius at which the force acts is sometimes called the moment arm. Next is how is torque calculated. The magnitude of the torque vector for a torque produced by a given force is torque equal to force times radius times sine theta, where radius is the length of the moment arm and theta is the angle between the force vector and the moment arm. In the case of the door that I have drew before, the force is at right angles 90 degrees to the moment arm. So the sine term becomes 1 and the equation changed to torque equal to force times radius. The direction of the torque vector is found by convention using the right hand grip rule. If a hand is curled around the axis of rotation with the fingers pointing in the direction of the force, then the torque vector points in the direction of the thumb. Next is how is torque measured. The SI unit for torque is the Newton meters. In imperial unit, the foot-pound is often used. This is confusing because colloquially the pound is sometimes used as a unit of mass and sometimes force. What is meant here is pound force, the force due to Earth gravity on a 1-pound object. The magnitude of these units is often similar as 1 Newton meters equal to 1.74 feet pounds. Next is what role does torque play in rotational kinematics? In rotational kinematics, torque takes the place of force in linear kinematics. There is a direct equivalent to Newton's second law of motion, which is force equal to mass times acceleration. The equation is torque equal to rotational inertia times angular acceleration. Rotational inertia is a property of a rotating system which depends on the mass distributing of the system. The larger the rotational inertia, the harder it is for an object to acquire angular acceleration. What is rotational equilibrium? The concept of rotational equilibrium is an equivalent to Newton's first law for a rotational system. An object which is not rotating remains not rotating unless acted on by an external torque. Similarly, an object rotating at constant angular velocity remains rotating unless acted on by an external torque. The concept of rotational equilibrium is particularly useful in problems involving multiple torques acting on a rotatable object. In this case, it is the net torque which is important. If the net torque on a rotatable object is 0, then it will be in rotational equilibrium and not able to acquire angular acceleration. And that's it for the video about torque. If you like this video, please press the like button, and thank you so much for watching.